Hi there. In this last section for today, I'm going to go through just an overview of some of the techniques that you might encounter in data analytics. Some of these we'll be doing in the subject. Some of them we're not going to. The first one is an unsupervised technique. So remember, this is about making sense of the data, and it's a set of methods called concept description. So here we're trying to characterization or discrimination. So we're trying to characterize some concepts or discriminate between different concepts. So as an example, Amazon might be interested in the characteristics of people who tend to purchase many books, and organisations might be interested in characteristics of emails to be able to discriminate between spam emails and work-related emails. So generally, you try to work out the general characteristics of a target class for characterization. Discrimination is trying to identify the features that are different. We're not really going to cover this one in the class this semester. Okay, the next unsupervised technique is called association analysis. There's other words for this as well. So there's association analysis, there's market basket analysis, and there's frequent pattern analysis. So all quite similar kinds of things. What we're trying to do is identify frequent patterns that occur in a data set, and in particular for the association analysis, we're trying to find frequent attribute value conditions that occur frequently. So some examples, if a person's age is between 20 and 29 and their income is between 20 and 29k, then that person buys DVDs. So the first part before the arrow is an if, the second part is a then. It's like if-then rules. Another example, if the transaction contains an MP3 player, then the transaction is likely to contain sound processing software. So again, it's an if-then rule. You can see underneath there it talks about this support and confidence. Support, these are measures of how often the rule holds. So support is the fraction of the data with attribute and value, so how often you see these in combination in the data set. So if it has a high support, that means that this rule is quite frequent within the data set. And then there's confidence. So confidence is how often the rule holds. So for the fraction of data with attribute, so the fraction of data where the first part's true, where the second part happens. So the fraction of transactions that have MP3 players that also have sound processing software. So it's a confidence. It's how confident you are that the rule follows. We're not really going to talk about association rule analysis in the class either. The one we are going to talk about in the unsupervised methods is clustering or cluster analysis. And there's lots of different methods that are involved in cluster analysis. So the general idea with this one is we're trying to identify groups within our data set where the data points in the group are similar to one another, but that are different to those in other groups. So we want to find data points in the group that are similar to one another, but different to other groups. Another way of saying that is we're trying to identify groups within the data that maximize the intra-class similarity, so that's the similarity within the class, that maximize the intra-class similarity, so maximize the similarity between classes, and minimize the inter-class similarity, so minimize the similarity within the class. So minimize the similarity within the class, maximize the distance between the two classes. So some examples might be trying to cluster students based on their mark and assignments. So you might find some students that all have similar kind of marks, but they're quite different to other students with other marks. So you could imagine that there's HD students versus barely passing students. So this is, of course, an unsupervised learning technique. So later in the semester, we're going to be looking at some techniques in clustering, including hierarchical clustering and some methods like k-means clustering and k-medoids clustering. The other kinds of techniques we're interested in this semester, and probably mostly we're interested, are the supervised learning techniques. And we're interested in classification and prediction. Classification, we're using historical data to find a model that describes or distinguishes classes so that we learn we learn the mapping between input and a target so that we can then use that model to predict the target of classes where we don't know the value. So an example might be we're trying to build a model to predict the grade of students based on the students who previously did the subject. And there's two kinds. When we're looking at discrete things, so like Z, pass, credit, distinction, high distinction, or whether we're trying to predict whether someone's going to buy a music file or not, so yes or no, when there are discrete things like that, that's called classification. If we're trying to predict a number, so if we're trying to predict their mark, the student's mark, or we're trying to predict the probability that a customer will purchase a download. So when we're trying to predict numbers, that's called regression or prediction. A lot of techniques that we'll look at throughout the semester will be these. There's some other techniques that are sort of oddball techniques that are sort of based on these, but not entirely. There's things called outlier analysis. Here we're trying to find data points that are quite different to other data points in the data set. So we're trying to find exceptions to the rule. So often fraud detection is described as this kind of problem. So usually in statistics, when you find outliers, so in statistics, outliers are considered as noise or an exception. In data analytics and data mining, usually the outliers are something that's really interesting because you want to find out why they're interesting. They might be interesting because either the data is wrong and it's incorrect, or maybe there's something that's really important like fraud. There's a whole lot of time series analysis methods. So these are looking at patterns over time. So looking for trends or deviations. You might be trying to predict the trends of share prices on the stock market. I put these as separate because time series analysis has a whole lot of methods that are really specific to time series. And that's because the data points, if you think about each value at each time, they're dependent on other data points. There's qualitative analysis. We're not really going to talk about this one, but here we're trying to divide the values of examined attributes into distinct qualitative regions and look at the behaviour in those. The last thing I want to talk about today is the way that we present results. So generally in data mining or data analytics, there's a trade-off between how easy it is to understand the model by humans versus how easy it is to use or how accurate the model is on the computers. So it's often the case that models that give a really accurate result are hard to understand, but the models that are understandable for humans are often not as accurate, that the results are not quite so good. So that means if you're a data analytics professional, you need to exercise judgment in the kind of model that you produce. Sometimes it's not that important that it's really, really accurate. It's more important that people understand how it works. And sometimes it's the other way around. And here's some examples of these. So we've got an XY plane here. The X's are the understandable by computers, so the accuracy, and the Y is the understandable by humans. So you can see that something like association rules or decision trees are really easy to understand for humans, but at least for association rules, they're not that accurate. Random forest, it's reasonably easy to understand by humans, but it's also quite accurate, but less understandable than decision trees. And then there's something like a neural network. It's quite accurate, but it's really hard to understand how it's solving the problem. The last thing I wanted to talk about was this idea of interestingness. Often we're interested in whether discoveries are interesting. So association rule mining, for example, can produce thousands of rules, but not all of them are interested. Not all of them are interesting to the business. They can't be made, you can't make decisions of them, or they're just not useful. So we can define interestingness measures, and we can say things, a pattern's interesting if it's easily understood by humans, if it's valid on new or test data with some degree of certainty, and it's potentially useful or novel or validates some hypothesis that we're seeking to confirm. And we can have different kinds of interestingness measures. We can have objective ones that are based on some statistics, for example, the support and confidence that we saw with the association rules, or we can have ones that are subjective, so they're based on users' belief in the data. So we could say we can have measures for novelty, and that will measure that kind of subjective interestingness. Okay, that's it for today.